Hi there, this video is going to take you through part 2 of chapter 7, section 2, which was verifying trig identities. So in the previous lesson, we talked about how this is basically everything you need to know, your same reference sheet that we use for 7 and 1, and then we worked through a bunch of the examples. Number 8 was one that we skipped. So if I look at this one, the left side is definitely less complicated than the right. So if I were to try to combine the right-hand side into one fraction, I'd have to give it a like denominator. The least common denominator here would be the combination of the two, so 1 plus cosine x and 1 minus cosine x, which means we're going to multiply each by the opposite's denominator. So this first one's going to get the 1 plus cosine x, and the second one's going to get the 1 minus cosine x. So I get 1 times 1 plus cosine x, or 1 plus cosine x, plus, which comes from the middle, 1 times 1 minus, which would be 1 minus cosine x, over 1 plus cosine x and 1 minus cosine x. In my numerator, I'm going to combine my like terms. 1 plus 1 is 2, and positive cosine and negative cosine actually cancel out. In the denominator, these are opposites. So if I multiply them out, I get the difference of two squares. This is one of my special products. It would be 1 minus cosine squared x. And we know that sine squared plus cosine squared equals 1. So if I move cosine to the side with the 1, I get sine squared equals 1 minus cosine squared, which tells me I can replace my denominator with sine squared. So 2 over sine squared x. And then if we want to move a trig function from the bottom to the top, we change it into its reciprocal function, which would be cosecant squared. And I get 2 cosecant squared x equals, and there's the other side, 2 cosecant squared x. We also skipped number 10. So on 10, we've got two statements with squares and ones. So again, if you look back onto your Pythagorean identities, you would see sine squared plus cosine squared equals 1, and you'd see tan squared plus 1 equals secant squared. So if I move around the 1 on the top and I move the 1 to the on the side with the sine, the cosine would go the other way, and I would get sine squared minus 1 equals negative cosine squared. So I can replace that with negative cosine squared x. If I manipulate the second one to bring the 1 on the side with the secant, I'd end up with tangent squared equals secant squared minus 1. So secant squared minus 1 is the same thing as tangent squared. Now tan is sine over cosine, so this would be sine squared over cosine squared. And then the cosines would cancel, and my negative would bump to the front of that sign. I'd get negative sine squared x equals negative sine squared x. All right, going out of order here because we're going back to 9. So in 9, on the left side, which is definitely more complicated, you've got two expressions that have squares with 1. So if you go back to your Pythagorean identities, tan squared plus 1 is secant squared. Cosine squared minus 1 is sine squared. Actually, it's negative sine squared. And then secant is 1 over cosine squared x times negative sine squared. If you want to put it over the 1 so you can see the two fractions, you can, but you don't need to. And then multiply those two together because nothing's going to cancel, and you get negative sine squared x over cosine squared x. And that ends up being negative tan squared x. Left side now equals the right side. (11) No squareds or sums here, but on the left-hand side, you've got tan and cosecant. Tan is sine over cosine. Secant is 1 over sine. And then the sines can cancel, and I get 1 over cosine, which is secant. Number 14 is cosecant minus sine of x equals cosine times cotangent of x. So you can actually start either side here, but because the left side is some are different, I tend to try to combine those. Cosecant would be 1 over sine of x minus sine of x. And then in order to get the same denominator here, I'd have to multiply sine of x times sine of x. And I'd get 1 minus sine squared x over sine of x. Our Pythagorean identity, sine squared plus cosine squared equals 1. So if I bring the sine over here, cosine squared would equal 1 minus sine squared. And I'd replace my numerator with cosine squared x over sine x. Now there's two ways to go from here. One is bring the sine to the top and make it cosecant, and then rewrite them as their reciprocals. The other is to separate out one of those cosines, because I know I want one cosine in my answer, and then multiply it times the cosine over the sine, and cosine over sine is cotangent. Okay, going back to 12. The left side is your sum, the right side is just a product, so I'm going to work the left side here. I'm going to make this sine x over cosine x plus cosine x over sine x. And then if I want to make that one fraction, I have to find the least common denominator, which is going to be the product cosine x times sine x. So the left side is going to get multiplied by sine, and the right side is going to get multiplied by cosine. I'd get sine squared x plus cosine squared x. That whole thing would be over cosine x sine x. Sine squared plus cosine squared is 1. And cosine would go to the top as its reciprocal function, which is secant. Sine would go to the top as its reciprocal function, which is cosecant. And left side equals right side. (13) Left side, cotangent is cosine over sine. Secant is 1 over cosine. 1 over sine becomes cosecant. Okay, 15, on the left-hand side, I would get 1 over cosine x plus sine x over cosine x. And I end up with 1 plus sine of x over cosine x. They're the same terms, but they're in the wrong spaces. So in order to move the cosine to the top, I'm actually going to multiply both the top and the bottom by cosine. So I'm going to keep working this left side, but if I worked the right side, I could have multiplied times 1 plus sine of x in the top and the bottom, like we did in the example from yesterday, and it would also get rid of it. But I'm going to keep going so we're on the same side, but that obviously is an option. Okay, so from the left-hand side, I would get 1 plus sine of x times cosine over cosine squared. And then cosine squared, if I want to get sine involved, sine squared plus cosine squared equals 1. So cosine would be 1 minus sine squared. 1 plus sine of x over cosine of x would go over 1 minus sine squared x. That can get factored into 1 plus sine of x and 1 minus sine of x. And then I can cancel through the 1 plus signs. And what's left is cosine of x over 1 minus sine of x. If you had reversed it, if you had worked the right side, I'd have to get rid of the 1 minus sign in the denominator by multiplying by 1 plus sign. And I'd get cosine x times 1 plus sine of x over 1 plus sine and 1 minus sine, which becomes 1 minus sine squared of x. 1 minus sine squared of x is cosine squared of x. One of the cosines cancel, and I'd get 1 plus sine of x over cosine of x. Now it hasn't equaled the left side yet, but if you remember from yesterday, we said if there's a fraction and there's a sum or difference in the top, I can actually split it into 2 fractions. This would have become 1 over cosine of x plus sine x over cosine of x. And that becomes secant x plus tan x. And now that equals the left side. So 2 completely different ways to do it. Obviously, both are right. Just depends on which one your brain makes more sense of. All right, looking at 16, on the right-hand side, you've got just sine, so you can't break it into its reciprocal or anything. On the left-hand side, if I rewrite this, one way to look at this is if I want to, so because the right side has sine and sine, if I wanted to get the left side to be the same, to work with the same trig function, I know cotangent and cosecant are linked in my Pythagorean identity. So 1 plus cotangent squared x equals cosecant squared x. And if I were to use that, if cotangent is on the side by itself, I would subtract 1. And I'd get cosecant x, or cosecant squared x, minus 1 over 1 plus cosecant x. And then the numerator can be factored. That would be cosecant x plus 1 and cosecant x minus 1 over 1 plus cosecant x. And then the 1 plus cosecants can cancel out, and I'd get cosecant x minus 1. Now, it still doesn't equal the right side, but at least I now have it in terms of its reciprocal function, which is that sine. So if I rewrite this, 1 over sine of x minus 1, and then I get a like denominator here, I'd multiply both the top and the bottom by sine, and I get 1 minus sine of x over sine of x. And this time, the left side equals the right. Looking at 17, it's a lot like that 16. On the left-hand side, you've got tangent and secant, and these are both in the same Pythagorean identity. This time, tan squared plus 1 would equal secant squared. So if I want tan on the side by itself, I would get tan squared equals secant squared minus 1. So secant squared x minus 1 over 1 plus secant x. I can factor my numerator again, difference of 2 squares, secant x plus 1, secant x minus 1 over 1 plus secant x. Cancel out the 1 plus or the secant plus 1s, and I get secant of x minus 1. Closer, but not there yet because I need to rewrite it in terms of cosine. 1 over cosine x minus 1, and I would put this as cosine over cosine, and I get 1 minus cosine x over cosine. And now the left side equals the right. Okay, if you look at 18, clearly the right side is more complicated than the left. On the right-hand side, tangent squared actually appears there on both terms. So if I were to factor that out, I'd get secant squared x minus 1. And go back to your Pythagorean identities. Tan squared x plus 1 equals secant squared x. If I move the 1 over here, I'd get tan squared equals secant squared minus 1. So I'd get tan squared x times tan squared x. And that means there are 4 there. So tan to the 4th x equals tan to the 4th x. Right side is more complicated than left. So if I were to work that first, inside the parentheses, they both have a cotangent. So if I want to factor it out, I would get cosecant squared x times cotangent x times 1 plus cotangent squared x. 1 plus cotangent squared x is cosecant squared x, so I can replace that. And then cosecant squared becomes cosecant to the 4th x times cotangent x. All right, that wraps up the notes for 7. Okay, that wraps up the 7.2 notes. So use the remaining time to work on the homework. Don't forget to submit those notes to the Canvas assignment. And again, you can use the remaining time to work on 7.2 part 2 or day 2 homework. Have a great weekend, guys.